Welcome to this SOILveR Coffee break. I will share my screen in a minute, but first our coffee break then will be structure about first a small introduction from my side on the SOILveR network. And then after we will have several speakers. We welcome them and we thank them for being part of this coffee break meeting. First, Sarah and Martina will give you some overview, general overview of the project, and then we will dig into the specific remediation techniques with Alessandro Argentini from Tesseco and Daniele Vezzoli and Gabriele Beretta from HPC. But first, some word from the SOILveR platform. Let me share my screen. So some words about the SOILveR platform, which is a soil and land research funding platform for Europe. Back in time, actually, when you look, we are existing since about 20 years, but we started first as a ERANET network under the label Snowman Network. Maybe you know about it. And so during the ERANET period, it was funded by the European institution, but then it went on as a self-financed network because the members wanted to go on with the sharing of research and co-funding project together. Then there was that call from the European level to build a strategic research agenda on soil and land. And so the Inspiration project took over that part. And during that time, we were more like doing other activities than building strategic research agendas, waiting for the results of the Inspiration project. And at the end, when the result was delivered by that project, then we modified a bit the network, the platform to take on board that strategic research agenda on soil and land and to go on and move on with the SOILveR platform itself. This is a platform which is funding research, but also more. We also exchange many experience on different topics. The idea is to, of course, benefit from a larger total budget and co-fund project and targeted action, and to make sure that the competence and the skills from across Europe, from the researchers and other communities are put together to deliver the best output as possible. We also have a strong relationship between platform members to dig into deeper, I would say, in specific topics. And the idea when we are funding research is to really try to produce operationable research results, such as guidelines, recommendation, and support tools for decisions. And this is the way we are organized within SOILveR, building on two pillars, exchange and development. The idea is to activate those two pillars, exchange and development, around the topics that we found of common interest. And we are strongly linked, of course, to the European soil strategy and the discussion that is coming and upcoming on the proposal for a soil health law. Here, there is a list of topics that we are discussing together, like risk assessment for polluted soil, be it from local or diffuse pollution sources. We also try to see more about tools for helping the policy decision. And we also are interested by the issue of circular economy, the contaminant of emerging concern, and all the discussion about soil ecosystem services and how to assess them. But also to see when there is a problem, how to restore them, and see what are the different options to put in place. This is linked also to the awareness raising and trying to integrate the value of soils in the different decisions that can be happening. So around such kind of topics, one pillar is more focused about exchanges. This is done through different open online meetings, like webinars or interactive workshops. Also, hotspot meetings. Those are meetings where people from one country are discussing together in their own language, but they are connected to other hotspots in other countries. So that's an interesting formula. We have also those kind of coffee break meetings that you are participating today, which are shorter meetings on one topic. And then, of course, exchanges inside and outside, collaborating with other networks and organizations dealing with soil and land. For the development, we gather our budgets and we co-fund action for research projects through, for example, calls, but also other types of targeted actions on common topics of interest. This is some example for the exchange knowledge pillar. We dealt with the PFAS topic, the lead topic, which is still a currently interesting topic. We also share, of course, the results from the project we finance. And last year we had a really focus on the discussion around the soil strategy and different aspects of it, like monitoring schemes, sustainable land use, and soil certificates and passports. On a shorter meeting like coffee breaks, we tackled bioaccessibility issue, also the vegetable gardens affected by pollution, and also biochar. And we have special collaboration with Common Forum, EEA, IANET working group, soil contamination, and Nicole. All that can be accessed on our website if you are interested in the topics and the type of exchange we have. The other pillar is mainly targeted about the development of knowledge. So we get larger budget and we collaborate between different countries. This is the pilot call that we launched in 2019, sorry. And this was on two axes. One focus on emerging contaminant in point source and diffuse pollution in soil and groundwater resources. And the other axis was around the integration of the value of soil in land use decision. You can see here the three project, premise, mystery, and SOILveR. Every result is available on the website, so feel free to go and have a look. And we are currently discussing the topics for next co-funding action. So this was some word from the platform SOILveR. If you are interested in our activities, don't hesitate to contact us and visit our website. You have all the information about the membership agreement and the secretariat fit, which is also associated to that involvement. So with that, I thank you very much, and I will leave the floor to the topic of today, and so the POSIDON project, and I leave the floor to Sarah and Martina to give you more information on that one. Thank you.
Thank you. So I would like to introduce this project. I just check if you are seeing the screen and my voice.
Yes, but put it in presentation mode if you would like, maybe.
Okay. Because I can see. Is now okay?
I think so.
Okay.
Okay. So thank you for this invitation. We would like to talk and introduce you POSIDON PCP project, which is a European funded project under Horizon 2020 framework. My role has been to provide public procurers involved in this project with know-how to apply the methodologies of innovation public procurement, and particularly in the implementation of pre-commercial public procurement, which is an instrument that enable the procurers to challenge the market and obtaining alternative technologies to be compared, as I will present in a few minutes. The pre-commercial public procurement has allowed 5 procurers around Europe, the Port Authority of Trieste and Bilbao City Council, plus 3 observers, SPACWE, Victoria Goidts City Council, and Valladolid in Portugal. And they have collaborate to voice out their unmet needs concerning the decontamination of their soils, and suppliers to compete while they developed new, efficient, and sustainable solutions to decontaminate organic and inorganic contaminants in heterogeneous soil and trophic soils. PCP, as you can see, is the yellow-orange part in this slide, concerns a purchase of R&D services, meaning the phase before the commercialization in a product development cycle. It has been articulated in 3 phases, covering activities such as solution exploration and design in phase 1, where we have a number of consortiums competing to develop new approaches and new solutions. A second phase dedicated to the prototyping and the validation of the new technologies in laboratory. And we had the phase 3 consisting in the field testing to demonstrate that the technology is suitable for production and deployment. So as you can see, we started from TRL 2, and the ambition was to achieve at least TRL 7. I think, but it will be the awardees that will explain about their solution. We have achieved increased TRLs. I see a comment here. So Martina, can you share the presentation in the presentation mode, because they are seeing your notes? Sorry. Okay, perfect.
Is it better? I'm sorry.
Yeah, it is better, yes.
Perfect. Okay. And they are distracting me. Perfect. So pre-commercial procurement started from TRL 2 and achieved TRL 7, if not 8 or, okay. It's important to say that the pre-commercial public procurement is not the decontamination work contract. So PCP, pre-commercial public procurement, is a mutual learning process and exercise for the procurers and the suppliers to get confirmation in the field, both about the functional needs on the demand side and the capability and eventual limitation that the new concept demonstrated in the field. It is important to stress that the pre-commercial public procurement is a multiple sourcing procedure. So we have a multiple number of consortium competing to develop these new solutions, and we implemented a cross-border procurement, which has involved Italy, Portugal, Spain, and Belgium. So 4 countries have cooperated, representative of 4 countries, and these enable these solutions to be applicable at European level. This opportunity has offered the possibility for the procurers not to be locked into some particular technologies. They had the chance to define their needs. And based on this international competition and a number of evaluation and assessment phases, we can announce that SOILomic from Teseco Bonifiche and Erase from HPC Italy solutions succeeded and have been selected as best value for money innovative in situ technologies to decontaminate soils polluted by petroleum, hydrocarbons, and heavy metals. Finally, we desire to extend and continue our work for inclusion of potential procurers or soil managers, stimulating the demand aggregation process. And we would like to address a bigger market on decontamination soil. So we have launched a call for interest, which is published in our website. providing the opportunity to join the procurers buyers network and follow on this process, assuring the uptake of innovative technologies capable to decontaminate in situ into the market. So I thank you, and I give the floor to my colleague Martina for the presentation of the
Yes, thank you,
technical
Sara. Yes, the common challenge faced by our procurers is to, or was, because we are now in the final phases of the project, to identify a new, not present already on the market, soil remediation, life cycle, cost-effective technology. We preferred in situ technologies capable to decontaminating at the same time, this is the real innovation, organic and inorganic contaminant in heterogeneous eutrophic soil in brownfield. So we have started from a single common conceptual model, harmonizing all the characteristics of the site engaged in POSIDON. And now we are in the phase 3, so in the real field testing sites where two similar sub-areas have been identified in Trieste in Italy and in Bilbao in Spain, where to test and compare the new technologies sought after, which are, as introduced by Sara, soilomic technology from the international consortium led by Teseco Bonifiche, and erase technology from the international consortium of HPC Italia. So I hand over the floor directly to Mr. Gentini from Teseco Bonifiche to introduce his technology. Thank you.
Thank you, Martina. Could you see my desktop?
Yes, thank you.
Yes, okay. Thank you very much. And I am Alessandro Gentini. I'm from Teseco Bonifiche, and I present the soilomic technology. Soilomic technology is a protocol, is an innovative protocol that combines the biological and chemical physical processes based on the integration of metagenomics, culturomics, environmental engineering, and aimed at the decontamination of soils and groundwater from organic and inorganic pollutants. It is applied in situ and through an operating technology named bioflashing, an original design plant that purifies contaminated groundwater and establishes a circulation of specific biological and chemical physical solutions in the subsoil, aimed to the degradation of organic contaminants and the leaching of inorganic contaminants. Soilomic employs a physical, chemical, biological conceptual model of the site. The microbiological dimension of conceptual model is supported by a multi-parametric analysis, serving the taxonomical study of the microbial communities autochthonous to the contaminated metrics. And the study of the soil and groundwater also takes place through detailed chemical, physical, mineralogical analysis, which involve all the natural components and contaminations. Soilomic consists in the integration of consolidated physical-chemical approaches with metagenomics and culturomics to assess and govern the process of decontamination of organic and inorganic pollution. And next generation sequencing methods is adopted to investigate the entire complement of organisms in the matrices of interest. This is called metagenomics. And the sequencing methods applied requires advanced bioinformatic instruments for handling huge amounts of data, offering meaningful biological interpretations of the same. At the same time, Soilomic adopts a culturomic approach to select microbial candidates that perform the metabolic functions required to achieve the goal, The goals are the degradation of organic contamination and the increase of the bioavailable portion of contamination. In parallel, through sequential extraction protocols developed directly on site-specific matrices, our technology allows the production of chemical solutions suitable for the desorption, transformation, and solubilization of inorganic contaminants. What is the function? Specialized biomass and chemical treatment used in specific in situ technology we called bioflashing. Bioflashing combines biological and chemical treatment cycles. The first cycles consist in soil improvement, biostimulation, bioaugmentation of the autochthonous microbial community for the degradation of the organic contamination. And the second cycle is a chemical flashing by leaching solutions studied during the second phase of the study of the project, the phase in laboratory. The targets of the technology is hydrocarbons, polycyclic aromatic hydrocarbons, PAH, polychlorinated biphenyls, chlorinated volatile compounds, BTEX, and organochlorine compounds as lindan and other pesticides, as well as on metals and metalloids as lead, cadmium, zinc, nickel, arsenic, that are the targets of POSIDON project. This is the process scheme. The plant consists in the injection wells suitable for different injection modes and pressure thresholds, the extraction wells, groundwater purification unit, an oxygen mixer, a chemical solution dosing unit, and a biological solutions dosing unit. And what the plant does? Bioflashing plant is designed to perform the following operation in situ: soil conditioning and hydrochemical microfracturing to improve permeability and facilitate the spread of treatment fluids, biostimulation, an improvement of soil by solutions enriched by oxygen, nitrogen, and selected soil improvers, by augmentation of matrices to be treated with inocula of the biomass selected for degradation, fungi and bacteria, fungi in the case of Trieste site and bacteria in the case of Bilbao site, chemical flashing of inorganic contaminants, and extraction of contaminated groundwater and purification of the same groundwater by physical chemical treatment and filtration. This is some photos of our plant in Bilbao. This is the field test, and this is the plant for the treatment and the dosing unit and the dosing of biological solutions. Some details. And this is the same plant we have installed in Trieste. So my presentation is ended. Thank you very much.
Maybe now the next speaker can...
Okay, just a second and I share my presentation.
We can see it, but can you put it in presentation?
Yes, just a second. Okay, can you see the right video?
Yes.
Okay, I can start. I am Daniele Vezzoli from HPC Italy, who is the lead contractor of our consortium, of our international consortium. And I would like to start presenting the principle of our proposed solution. The technology under development by HPC has been named ERASE, electrode-aid soil remediation. ERASE is an in-situ electro-based remediation approach to integrate physical, chemical, and biological mechanisms for the cleanup of the contaminated sites. The technology offers an in-situ flexible platform for addressing various organic and inorganic pollutants and co-contamination either in the unsaturated or saturated soil and backfill materials, which are the innovative aspects of our technology. The ERASE aims at properly using the different mechanisms put into action under their operating condition. So our consortium aims to find such conditions to enhance and co-use the effects of many combined remediation mechanisms. Differently from other approaches, the proposed solution can be effectively applied to both fine and coarse grain materials. Another important aspect is the modularity of the proposed technology that allows operation on contaminated sources of different extensions and depths. Then other innovative aspects of the solution is that the ERASE has a totally in-situ approach, so no significant excavation and disposal of soil is required. And also that the estimated limited requirements of materials, equipment, and energy in comparison to other established technologies, like, for example, dig and disposal, make our proposed innovative solution as a sustainable and cost-effective approach. We have to underline an important point for this presentation, and that is the technology will be subject of a patent application by the end of April 2023. And for these reasons, details about the technology cannot be disclosed at the moment. Our patent application is quite ended, but at this moment we cannot talk about the details of our technology for these reasons. After the end of the month, we can spread more details about the technology. Okay, so we can show the most important goals of research and development of our technology. And in particular, we have the capability to reduce concentration of different kinds of pollutants and at the same time, both organics, like, for example, TPH and PAH, and inorganics as heavy metals. Then another important goal of our research and development is the totally application of our technology in situ, because it's a technology that is applied only in situ without the significant excavation of soils on the other material. Then another important point is the capability to operate at small to large scale area with different depths, because our technology is a modularity technology that can be adapted to different kind of site and dimensions. Then another goal of our research and development is the limited influence of soil texture and permeability, because our technology is able to treat also medium soil with a low permeability, because we do not depend only by the water conductivity, but also other parameters. So we are able to treat also soil with low conductivity, like, for example, clay, or clay. Then adaptability to environmental modifications, minimal footprint, and minimal impact related to social aspect. No acoustic, visual, and traffic impacts are expected by our technology. The status of our research and development is summarized in the following slide. The phase 1, the feasibility study, has been completed in 2019. Then in phase 2, then we completed also the phase 2, that is the lab test, completed in 2020 and 2021. And then we have also completed the phase 3 by considering the execution of the 2 pilot tests in Bilbao and Muggia in Italy, in Trieste. The pilot tests were completed in February, and the results are being processed. In the next slides, I want to show the relevant outcome of phase 2 lab test. An extensive set of laboratory tests up to a 3D electrode aid remediation test was performed to investigate the proposed remediation approach based on the driving forces induced by powering the system. In this picture, you can find a prototype of a lab test that we have studied during the phase 2. The results gained on the real historically contaminated soil in laboratory suggest that the integration of all involved mechanisms allows to obtain an effective metals removal recovery and an extensive in situ organic pollutant degradation, referring to, like, for example, for the heavy metals, like, for example, copper and the other metals that you can see in the slide. And for the organic pollutant, you can consider petroleum hydrocarbons in general and PAH. In this table, you can see the efficient removal that we have gained during the phase 2, during the lab test, in which after about 2 months, we reached the contamination efficiency about of 60–70% for all the compounds that we have analyzed. These are some pictures of our pilot test site at the beginning of the experimentation. After the conclusion of the protection of our intellectual rights, we can spread more pictures and more details about the technology of the experimentation. In the end, I would like to show the potential application of our technology in the market. In particular, the potential strengths in the remediation market are the following: treatment of complex heterogeneous contamination, contemporary remediation of soil backfilling materials, chance to perform the remediation in lots because our technology is has a modularity approach. The complete in situ application of the technology with low acoustic, visual, and traffic impacts, limited emission and landfill operation, flexibility and adaptability to set specific requirements, and the possibility of outsourcing and to apply economies of scale. The context of application of our technology are the following: multiple contaminated brownfields, productive sites, large real estate redevelopment areas, and coastal sites. And thank you for your attention.
Thank you very much. Maybe we can have then time for some questions. I see that some questions are in the chat. Marta, maybe you can take over for discussion.
Yes, indeed. So thank you from my side also to both to the presentations. So we had 2 questions. Just let me see in the dialog box. So the first one was about the usual order for the first question was about the first technology, the soil omic technology, and the rationale or the advantages to follow first the to start with the biostimulation that is followed by the chemical in situ treatment. So this question was answered. I don't know if you want some other precisions about this.
I've answered very short terms, but obviously the order of the cycles is decided based on the conceptual model of the site, the toxicity of the matrix, the contamination concentration, the soil texture. But usually we because of the leaching solutions shock the microbial ecology, we prefer to the first cycle is the biological cycle. So biostimulation and bioaugmentation first, and the second part is the leaching by some solution oxidant and reductant solutions.
Okay. Is it good enough as an answer? Dietmar? Okay, so we'll continue with the second question regarding the soil omic technology. So what residence times are needed in the soil for the biostimulation and the chemical step?
The technology establishes a continuous flow in the unsaturated soil. So resident time is not the right term. The duration of the treatment is important, and obviously depends on many factors: concentration of pollutants, soil texture. I think it's very difficult to speak about a duration of the treatment. In the case of the sites of the POSIDON project, we can say that a period of 6 months is necessary to reach the goals that are the legal threshold for the contaminants.
So you have some kind of legal requirements of processing with any new technology on site for at least 6 months, if I understand well.
In the case of POSIDON field tests.
Okay. Yeah. Okay. Okay, thank you. Does it answer to the question of our attendee?
Yes, thanks.
Okay. Thank you also. So we have another question from Anya NL. I imagine that it's about the both technologies. The question is, did you follow degradation products of PHAs such as oxy-PHA or other PHA?
I answer first. We know there are some degradation products that are more toxic of the original pollutant, and this is the case of PAH, and we follow the degradation also of these products. So for reaching the target of legal threshold, we need 4 months. But if I want to lower the toxicity of the matrix, I need 6 months, because I have to degrade also the degradation products of the original compounds.
Okay, and probably Mr. Vezzoli.
Okay, for HPC, I introduce my colleague Gabriele Beretta if he wants to have some consideration about this point.
Yeah, thank you, Daniele. Yeah, about the degradation of subproducts of the polycyclic aromatic hydrocarbon degradation. Yeah, we follow the other byproducts and taking into consideration the speciation of these hydrocarbons, and also we follow the other contaminants that are not included in the institution requirements. So we want to follow all the hydrocarbons, contaminants, hydrocarbon solution, just to have an idea of how our technology works. And the idea is to perform our results, our technology in the idea to be sustainable for the environment and also for the health of the environment and the human and the people who work around the site, the polluted site.
Okay, So we have another question. So what is how is the cost of these techniques compared to more classical solutions with similar efficiency? I would also add what is the added value of both techniques rather than the classical methods also.
Okay, I can answer for our technology, for the erase technology. We are evaluating the efficiency of the technology in terms of the contamination and considering the results of our two pilot tests that we have carried out in Trieste and Murcia. And we are updating the cost, and at the moment, also taking into account the significant increase, for example, in land disposal price. Our technology is a valid economic alternative to excavation and disposal, because one of the most important point is related that we have a very low production of waste, and the technology is completely in situ. And so we believe that our technology can offer a valid economic alternative to the classic remediation technology in the market.
Yeah. Okay, thank you. And Mr. Bonifice?
First, our technology is one technology that makes reach more targets of a classical solution. We treat the unsaturated and the saturated soil. We treat with one plant, one process, inorganic and organic contamination. This is very important because to reach the same goals, you need many technologies, many classical technologies. And the costs of our technology is similar to a water treatment. Is similar to a pump and treat treatment. So it's a very low cost to have a decontamination of soil.
Marta, if I can jump in just to underline that this was the real challenge of POSIDON. POSIDON KPI were the funding of a sustainable solution, and the time of intervention and the cost of intervention was the most important KPIs to be obtained.
Yeah. Okay.
So we are really happy with the result we are obtaining.
Yeah. I want also to ask the both technology developers, do you have some operational windows for both technology in terms of some site characteristics on which each of the technology could be applied? I mean, of course, we have the pollutants that you have mentioned. Do you have some other specificities of the site? For example, for the erase technology, do you need to have some access to some power source in order to use the electrodes, or?
Yes, our technology is an electro-based remediation, so we need to have a connection with the power grid to supply the alimentation of our technology. However, as our technology is characterized by a modularity approach, and it can be applied also for large sites. In this condition, if we have a lot of soil to be treated, we can consider also to not only use the power grid connection, but also to increase the sustainability of the intervention, using, for example, renewable energies. That is this decision depends on the dimension of the remediation works. If we have any remediation work with a lot of square meters to be treated and also a significant budget for the technology, we can think to introduce also a component of renewable energy to reduce the impact of our technology. And this for the point of view of the electricity consumption. Our technology, however, considering the results of our 2 pilot tests, has not a very high consumption of energy. So this is a very important point. However, we have to consider that our technology is a very site-specific technology. So changing the site, we can have other kind of condition to be considered. And also the increase of electricity consumptions can be verified by every site, because the grain of the soil, the texture of the soil can increase the consumption of electricity, and also the different modalities of conduction, of operational conduction of our technology that can be chosen only with a site-specific study can modify the energy consumption. However, the energy consumption is an important matter of our technology because it's an electrode aid remediation approach.
Yeah. Thank you.
Yeah.
And yeah, for the soil only, we have something to.
There is a last question, it seems.
Yeah.
Yeah, let's take that last question, and then I think we will go to the end of the coffee break. So
yeah. So for the soil omic technology, are the microorganisms directly produced on the site, or they are produced in a laboratory and then bring to the system on the polluted site?
Yeah, it's very interesting. We use autochthonous microorganisms. So we have to select the microorganism in a laboratory from the matrices taken on site. And then we bring back this microorganism on site, and we grow this microorganism in a specific part of the plant.
okay, thank you very much. Thank you very much to all speakers and to the participants. I think it was very interesting, a focus on such kind of technology. And I see that in the chat, there is the link to the call of interest, which is still open, so don't hesitate to use it. And we thank you all, and we might see you at the next coffee break that we organize. So thank you very much.
Thank you.
Thank you.
Thank you for the invitation.
Thank you.
Bye-bye.
Thank you.
Bye.
Bye. Bye.